Let's talk about electroplating. To start off, let's see if this reaction between copper and copper sulfate is spontaneous or non-spontaneous. So let's start by filling in our list here with substances that could be oxidized or reduced. Copper solid is going to stay in that form. Copper sulfate, if we look at our ion table, we need one copper and one sulfate ion, so that must mean it's copper 2+, since sulfate is SO4 2-. So those are going to go into our list. Since copper sulfate is aqueous, that means we also have water that can be put into our list to round it out. So now we find the substance that is easiest to oxidize. Most likely going to be a metal, and the only metal we have is copper, so let's see if we scan along if that holds true. So as we keep scanning, you'll see for sure that copper is the substance that is oxidized. Makes sense since it's a metal. So copper is oxidized, and here is the half reaction and the voltage for that process. So then what substance would be easiest to reduce? It's going to be one of these three things here. Most likely an ion. So let's look at the reduction side of our redox table, and we're scanning along looking for the substances in our list. If we don't have to scan far, we see copper 2+ is highest in the list. So copper 2+ would be reduced. Here's the half reaction for that process. Happens to be a positive 0.34 volts. We have 2 electrons transferred during this process, so those cancel. When we add this together, we get an interesting net ionic equation. Copper plus copper 2+ ions gives you copper 2+ ions plus copper. So the products and reactants are the same. You get a voltage of 0, which would mean this is a non-spontaneous process. However, if you apply a voltage to this reaction, you can actually get this reaction to occur, and you can get copper ions becoming copper metal. And that is the basis of electroplating. So we are going to create what's called an electrolytic cell. An electrolytic cell is when you apply a voltage to drive a redox reaction that is non-spontaneous. So you get a non-spontaneous reaction to occur by applying an electric current. So this is called, like I said, an electrolytic cell, and it is the basis of a major industry of electroplating. Electroplating is the process of plating out a metal on top of another surface. So this is best seen on like costume jewelry. So instead of buying expensive gold and silver jewelry, you can actually plate gold and silver on top of a cheaper metal, and it still looks nice, but definitely not as expensive as pure gold or silver or other highly valuable metals. Chroming out car parts actually helps protect them from oxidation and rusting. Maybe you have some cheap jewelry or a clock at home that is electroplated. You can actually electroplate leaves and flowers. And that's kind of a cool little piece of art. We are going to electroplate a quarter. We're going to put a coat of copper metal onto a quarter. So let's go to page 5 and we'll explain how this process occurs. So here's the little setup you're going to have in the lab. First off, you're going to have a copper strip and a quarter in a copper sulfate plating solution. We're going to go ahead and label both the electrochemical cell and the electrolytic cell with the following terminology. So we'll start by putting the copper ions and sulfate ions into solution, and then we'll label our electrochemical cell. So the negative terminal of our battery or our power supply will be connected to the quarter. The positive terminal will be connected to the copper wire that's inside the plating solution. The negative terminal of a battery, an electrochemical cell, is the anode, while the positive terminal is the cathode. Remember, oxidation occurs at the anode and reduction occurs at the cathode. Well, oxidation is losing electrons. So that means electrons are going to be lost from the anode, and they're going to travel out of the anode, down the wire, into the quarter. So the quarter is going to have a buildup of negative charge. The electrons are going to flow and fill up that quarter with negative charge. So copper 2 plus ions will be attracted to that quarter. Well, they will go to the quarter, pick up 2 electrons, and become copper metal. And that copper metal will plate out on the quarter and make it look fancy and shiny and new, like this. So copper 2 plus becoming copper metal means copper 2 plus is gaining 2 electrons. It is being reduced. So the reduction half reaction is copper 2 plus 2 electrons gives you copper metal. Remember that the process of reduction occurs at the cathode. So for the electrolytic cell, the quarter is acting as the cathode. The copper metal then will act as the anode. So how does that happen? Well, a copper atom is going to lose 2 electrons and become copper ions. This is the process of oxidation. So the electrons are going to be pulled out of the copper metal into the battery, which completes the flow of charge for the battery. So copper metal becomes copper ions and goes into solution. Remember, oxidation occurs at the anode, so the copper metal, the strip of copper metal, is the anode for the electrolytic cell. The electrons travel out of the anode for the electrolytic cell into the cathode of the battery. So we can complete our flow of electrons by drawing these arrows from the anode of the electrolytic cell to the cathode of the electrochemical cell or the battery. So we can finish this up here by drawing the flow of ions. Copper ions are positively charged. They're going to be attracted to the cathode. Cations to the cathode. The sulfate ions are negatively charged. They will be attracted to the anode because the anode has a buildup of positive charge. Remember, anions to the anode. And that is how you draw the electrolytic cell. This shows what's going to happen to your quarter in the lab today.